Hello everyone, I am Sukhpal Singh, Lecturer of Cloud Computing at Kumar University of London, UK. In this video, I would like to discuss about our recent research work published by Elsevier, that is drone-based network system and methods for combating coronavirus disease, that is COVID-19 pandemic. So this research work has been done by a team from Australia, India and UK. This work investigates the drone-based systems, COVID-19 pandemic situations and proposes an architecture for handling pandemic situations in different scenarios using real-time and simulation-based scenarios. The proposed architecture uses wearable sensors to record the observations in body area networks in a push-pull data fetching mechanism. The proposed architecture is found to be useful in remote and highly congested pandemic areas where either a wireless or internet connectivity is a major issue or chances of COVID-19 spreading are high. It collects and stores the substantial amount of data in a stipulated period and helps to take appropriate action as and when required. Now the Sagar will give you a demonstration about real-time drone-based healthcare system implementation. Let us see. So in real time, drone-based healthcare system implementation for COVID-19 operations. So it is observed that a large area can be covered for sanitization, thermal image collection and patient identification within a short period, that is 2 kilometers within the 10 minutes approximately, through the aerial route. Now Adarsh will explain and demonstrate 2D, 3D and design model for COVID-19 sanitation simulation.
This one is a 2D model on 2D for COVID-19 sanitization simulation. And in this one, this blue rectangular box or the square box are for the zones. And this completely is a 2D model, and the various processes are configured through a components, the different components, and you can see the statistics above, which shows the movement of drones. This one is a 2D picture of the working, and this simulation is selection of a drone and the zone. So one drone will select one zone. So on the right hand side, you can see the list of the events. All of these events are recorded and database is prepared. Now we'll come to the 3D simulation of this. So in 3D simulation, we can see one drone is selecting one zone at a time. So we can speed up this simulation and we can execute it for 100 days, 250 days, 500 days, 1000 days, or there is a virtual mode which shows that there is an automatic process for faster execution. We cannot specify the time, but it will be for infinite execution. This one is a 2D, the model which is designed using any logic, and there are processes associated with this. So each drone is configured with the set of processes. The drone zones are defined, the communication among the states are defined, the sanitization process here is defined. So this one is one simulation. Similarly, we have another simulation which shows the exchange strategy, like how drone exchange the zones. So this is one strategy. Like in our paper, we propose two strategies. One is a multi-layered strategy. Second one is a single-layer strategy. So presently, I'm presenting a single-layer strategy. So this one is an execution of the single-layer strategy. So so this one is a 2D execution, and we can see this one is the 3D execution. This one is a 3D execution. I'll speed up to show the results. So this one is zone exchange mechanism. So drones are changing the zones. So they're providing services, sanitization by staying there. So services are configured and zone exchange mechanism is configured. So
In the simulation, the same results are observed with an addition of collision-resistant approaches working successfully for indoor and outdoor healthcare operations. So apart from this work, we have also proposed many open challenges and research directions for the researchers. So this is basically a reference for this research work. Please feel free to contact us if you have any doubt or any query. Thank you very much for watching this video. Thank you.